Yeah, so good evening everyone. Good evening. Yeah, fine, perfect. I think we can start. Good evening. We can start now. Can we go ahead? Yeah, let's start. Thanks everyone. Thanks everyone. Audio video is okay or not verify? Yeah, I'm starting the today's class. So if you see the today's class, let me check. Yeah, I think everything is perfect. We can go ahead. So this is the today's class. Quicksort algorithm. Right, today topic is a quicksort algorithm. See this quicksort. Careful everyone, today is a quicksort algorithm. So what exactly quicksort algorithm? So remember everyone, quicksort algorithm is based on the partition algorithm. Quicksort algorithm is based on the partitioning. Right, the goal is means how will you partition? You may say that quicksort means this is the array you will partition, but how will you partition? Right, based on the pivot element. Based on the pivot element, suppose if you take this as the pivot element, then what happened is after partition algorithm is over, less than pivot will go to one side, more than pivot will go to another side. Right, I'm repeating the quicksort algorithm clearly. What is quicksort algorithm? Everyone know it is a sorting algorithm. Everyone know it is one of the sorting technique. That's everyone will understood. Okay, I'm happy with that. Next one. So how it will sort? It will sort based on the partitioning algorithm. Oh, you will do partitioning. How will you do partition? Based on pivot element. Suppose if you take some element as a pivot element, suppose third element you take as the pivot element, then what happened is less than the third element will go to left side, more than the pivot will go to right side. Some people are asking, sir, less than pivot will go left side, more than pivot right side. That's okay. But left people not sorted, na sir. Right people not sorted. Pivot is sorted. After partition algorithm is over, pivot sorted. Less than pivot will be left side. They may be sorted, they may not be sorted. More than pivot on the right hand side, they may be sorted, they may not be sorted. Then how will you sort left people, right people? I will apply recursion. See, elements smaller than the pivot are moved to left side. Elements greater than the pivot will move to right side. Okay, next one, the pivot itself is then in its final sorted position. So what I mean to say is after partition algorithm is over, pivot element will go to correct place, because my left people correct, my right people correct means I am correct. Suppose assume that you are at a particular place, left people also don't have any issue, right people also don't have any issue, that means you are there at a correct place. Right, you are there at the correct place. What is the meaning of you are there at correct place? Left people also saying that, left people saying that we don't have any issue with you, right people also saying that we don't have any right issue with you. Some people what is the meaning of we don't have, right? So that is the meaning of sorting party, right? Pivot element is saying that I am perfect in the sorted array, I am perfect. What is the meaning? Left people of him is perfect, right. Left people of left to him is all are smaller, right to him is all are greater, so he is correct. But remember, left people may not be, within them there may be a problem, right people within them there may be a problem, but comparing pivot, no problem. Partition algorithm is over based on the some pivot element, means pivot element is sorted less than the pivot on the left hand side, but they are not sorted. Right hand, right, more than the pivot on the right hand side, but they are not sorted. Next one, this process is applied recursively to the left and right subarrays until the entire list is sorted. Some people, right, from now onwards, if anyone asks you what is quick sort, simply say it is one of the sorting technique. Immediately people will ask, it is one of the sorting technique, okay, because it is a quick sorting technique. It is one of the sorting technique, okay, but how it is designed? It is simply based on the partition algorithm. Partition algorithm means what? It will divide the given array into some parts. Next one, how it will divide? Based on the pivot element. Okay, based on the pivot element, you applied the partition. Then what will happen? So based on the pivot element, if you apply the partition, less than the pivot will go left hand side, more than the pivot will go to right hand side. That means left people are all went to the, sorry, pivot element left hand side all smaller than less than pivot will be there. Right hand side all greater than the pivot will be there. So middle will be pivot will be there. So that means pivot only sorted, other people are not sorted. This process will be applied again on left people, again on right people, keep on continue until total array will be sorted. That is a rough idea. I think some people got that clarity. Now some people are asking, okay, partition algorithm, quicksort is completely based on the, quicksort is completely based on the partition algorithm, right? But first of all, can you give the algorithm for quicksort? Very simple. See this one, quicksort. Quicksort, it is the first element position, it is the last element position. Suppose array contain 10 people, it may be 0, it may be 9. So go inside. 0 less than 9, indication that elements are there to sort. Low less than high, yes. Then what you do is, first of all, apply partition. Whenever you say partition, right? So I think let them that this is the array. You done the partition algorithm. It finally return assume seventh element. It finally return assume that 7. What is the meaning? The person who is there in the 7th position already sorted. Before 7th should be sorted, after 7th should be sorted. Before 7th should be sorted, after 7th should be sorted. So please be careful. Right? So now understand everyone try to understand. Partition algorithm is over, pivot element will be sorted. Pivot element will be sorted. Assume that it returns 7. That means the element which is there in the 7th position already sorted. Before 7 should be sorted. After 7 should be sorted. So before 7. So what are those? Low 2. Assume that index, right? Pivot index -1 6. Right? 0 to 6 should be sorted. 7th person is already sorted. It's okay. Next one. Who are the next one? Pivot plus 1. I think 8 to remaining people will be sorted. Let us assume that 15 people, 8 to 15 will be sorted. So first apply partition algorithm. It return, right, pivot element position, right, after completion of the partition. Assume 7. Before 7 should be sorted using recursion. After 7 should be sorted after recursion. So this is the quicksort algorithm. Everyone know it is a recursive program. For every recursion, non-recursion also possible. So it is a recursive program. Now go to the partition algorithm. Everyone try to understand. Go to the partition algorithm. So, right, many partition algorithms are possible. So I'm just written the one form of the partition algorithm. Many ways are available. Don't worry. Right, many ways are available. But here, see this one. Pick last element as the pivot. You can take any element as the pivot, no problem. Pick the last element as the pivot. Pointer for the smaller element. I is equal to low -1. So I will execute one time. You can check, right? You can check carefully here. So there is one example also there. Please be careful. Make sure if you know partition, you know quicksort algorithm. 10, 80, 30, 90, 40, 50, 70. See this one. 0, 1, 2, 3, 4, 5, 6. This array contains totally 7 people. So 0 to 6, totally 7 people. Now you can see the algorithm one time. Pivot element is equal to array of high, right? I think 0 to 7 elements, not total. 0 to 6, right? Low is 0. High is 6. Now see, pivot is equal to array of high. I is what? 6. Array of 6, how much? 70. So pivot is 70. Remember after partition algorithm is over, 70 will go to correct place. Okay, that is okay. I is equal to low -1. Low is what? 0. 0 -1 is what? -1. So I is -1. I is somewhere here, which is -1. What is the J? Right? For J is equal to low to high -1. I think high is already 6, na? 6 -1, 5. 0 to 5. J loop is going on 0 to 5. Remember, J is initially 0. J is here. Yeah, let's wait 1 minute. Let's go just 1 minute. Yeah, so let me explain this. Partition algorithm I am explaining. I is equal to -1, j is equal to 0, right? J is equal to 0. So remember, so right, low to high -1. So until here you have to check, because he is a pivot element. You would taken last element as the pivot element. Remember, pivot element is equal to 70. Pivot element is equal to 70. So try to understand. Pivot element is the last person. You can take any person, no problem. Just I written one algorithm where pivot element is the last element. So I is equal to initially, I is equal to low -1, I is -1, I is outside. J is initially starting place. J is initially starting place. Remember, I, J are the indexes. P is the pivot element, not position. P is 70. Right, careful, everything is ready, everything, remember. And one more thing is, whenever smaller I will come to the picture, whenever bigger J will come to the picture. Try to understand this also. Comparing pivot, smaller people are coming, right? So then I will come to the picture. I saying that I want smaller, J saying that I want bigger. J saying that I want bigger, I saying that I want smaller. Try to understand. So now you can start the story now, right? See the story. See the story, what happened. Everyone observe, right? I is equal to low -1, I becomes -1. J is equal to low to high -1. High is 6, so 6 -1 is 5, 0 to 5. Right? J loop is going on. See this one. Array of J. J, I think J is 0 initially. A of 0. A of 0. So 10. Is 10 is less than or equal to pivot. 10 is smaller than, right? 10 is smaller than or equal to pivot. 10 is smaller than or equal to pivot or not, verify. Yes, it means that means smaller person is came or equal person came. Then what they are, right? What this algorithm will do is, everyone knows smaller means I will come to the picture. I is equal to I plus 1, then swap it. I is equal to I plus 1, swap with A of I, A of J. Smaller or equal coming, I will increment and you have to swap. Right? I will come, you have to increment, right? Now let me check here. I'm checking. Hey, class. Right, perfect. One of the kid is throwing the some doors and all, so I shouted. Yeah, now come back. I is equal to -1, J is equal to 0, pivot is equal to 70, everything is perfect. Now see this one. So loop is started. Loop is started. J value 0, A of 0, 10. 10 less than or equal to 70 or not? Yes. Means less or equal came. Yes. Then I will increment, I will come to the picture. Let me change the color. So I will become 0. I will become 0. Okay. Then afterwards, swap A of I, A of J. After making I as +1, swap A of I, A of J. Swap it. I think after making this one, I and J both are same. Swap A of I, A of J. So 10 replaced by 10. Okay. After swapping is over, I think it is there in the for loop. Right. Right. So now let me check here. So after swapping is done, as usual, you are there in the for loop, you will continue this. What is the meaning of continue? Right? I think next J value. J value becomes 0 over. Now J value becomes 1. Continue now. J value becomes 1 now. As usual, J will increment. See, whether you like or not, J will increment. So J will go here. As usual, check again. As usual, check again. What is A of J? A of J is 80. 80 is less than or equal to 70. 80 is less than or equal to 70. Condition is fail. So remember, condition is true, then only I is equal to I plus 1 swap. If condition is fail, you no need to swap. Right? You no need to swap. As usual, J will go to next position. J here. Again, J will ask, wherever I am, is it less than or equal to pivot or not? Yes, true. Then what you do is increment I by 1, increment I by 1, right? So I think I by 1 means I will become here. J already there, swap with it. So 30 will be here, 80 will be here. After swapping is over, as usual, J will go. J will be here. So again, J will ask, are you smaller or equal? No. Are you smaller or equal? No. Then what the answer? Smaller or equal? Then only I will come to the picture. Right? Otherwise, right, as usual, J will grow. Are you smaller or equal? Comparing pivot element, are you smaller or equal? Yes. Yes. Then I will increment by 1, right? I will increment by 1. I will come here, swap A of I, A of j. Then it will become 40 here. Then it will become 80 here. So as usual, j will go. After swapping is over, j as usual will go. J going here. So again check if A of j is less than or equal to pivot or not, verify. Yes, true. True. As usual, I increment by 1. So I will be here. I will be here. So j will be, I think what the answer, swapping is done. So it will goes to 50 here. It will goes to 90 here. Afterwards, as usual, j will increment by 1. But remember, so j will going from 0 to high minus 1. High is 6, 6 minus 1, 5. But j value now 6, I think out of for loop. Whenever you are out of for loop, remember everyone, whenever you are out of for loop, try to understand. Whenever you are out of for loop, please be careful everyone. Whenever you are out of for loop, what you do is, right? So I plus 1, right? And j value. Can you see the last one? Swap A of I plus 1 high. So I plus 1 means this person, and j, right? Wherever j there, swap it. This is going to be 70. This is going to be 80. Right? Afterwards, return I plus 1. Return I plus 1. So this is return I plus 1. I think 4. This is going to be 4. It will return 4. It will return 4. So the purpose, what I want to say directly, there may be so many partition algorithm. One partition algorithm I want to explain. Some people are asking, sir, after partition algorithm is over, can you show the output? Let me show now. Partition algorithm is over, it return 4. That's okay. How the elements look like? Let me check. 10 here, 30 here, 10 here, 30 here, 40 here, 40 here, 50 here, 40 here, 50 here, 70 here, 90 here, so 80 here, 1 2 3, sorry, index is starting from 0 na. Let me check. It is a 0, it is a 1, it is a 2, it is a 3, it is a 4, it is a 5, it is a 6. 0 to 6, right? 0 to 6, that's okay. It is a 4. Remember 4. Remember what is the 4? Pivot element position. Some people are asking, what about before pivot? All are smaller or equal? What is after pivot? All are greater. Right? Partition algorithm will divide the given array into two parts: less than pivot one side, more than pivot another side. So, but remember, until now I applied only partition. So partition algorithm is over, means it return 4. Then who should be sorted? 0 to pivot element minus 1. So 0 to 3 should be sorted. Who should be sorted further? So pivot element plus 1, 5. 5 to 6 should be sorted. So I think that is the right little bit of idea I given to you. Now listen. Partition algorithm I applied 0 to 9. Assume 10 elements are there. Partition algorithm I applied 0 to 9. Right? So is 0 less than 9? Yes. Apply partition. Let us assume that I applied partition. It returns 6. That means pivot element is finally went to 6th place. That means 0 to 5 should be sorted. That after 6, what I mean, 7 to 9 should be sorted. So this is going to be 0 to 5. This is going to be 7 to 9, like that. This is the partition algorithm. Apply recursion left side, apply recursion right side. It is keep on going. So many algorithms possible. I written one algorithm. But if you observe clearly, one for loop is there. See, one scan. If you want to send all small people one side, all greater people other side, if you want to do that, right, compulsory you have to do one scan. Right? If you want to send all the people, small people one side, greater people another side, one scan compulsory required. You have to do one scan. One scan means time complexity order of n. Same thing I explained here clearly, step by step I explained. Step by step I explained. Nothing is there. I took one numerical example. I explained step by step. Now some people are asking, sir, what is the time complexity of the quicksort? See, time complexity of the quicksort Tn is equal to, right? So you have to apply partition algorithm, which will take n time. So left, supposition that left p people came. Supposition that n elements are there. I applied the partition algorithm. N1 elements went to the left hand side. Assume n2 elements went to the right hand side. Assume that. So right? After partition algorithm over, n time over, left side is some people came T of L, time complexity. Right side is R people went T of R. This is the time complexity recurrence relation. So then what happened is, if you are lucky, n for partition, left L people, right R people, let us in that left and right 50-50, Tn by 2, Tn by 2, which will becomes, right, 2Tn by 2 plus n. So this will goes to n log n. So time complexity of the quick sort, if at all best partition happened, n log n time complexity will come. So time complexity of the quick sort is best case n log n. Right? Pivot always split the array into two equal parts, 50-50. Suppose, right? Suppose many combinations are happened. Sometimes 50-50, sometimes one third one side, two third another side, sometimes 1/4 another side, sorry, 1/5 another side, right? Other side is 4/5. So if at all the things if you take, average also become n log n, typical for random distribution. Every time same way, not dividing, some randomly all possibilities are covering, right? It is also n log n. Suppose if you are unlucky, then what happened is, after applying a partition algorithm n time over, if you are unlucky, L people left side, R people right side. Let us assume n for partition, left hand side 0 people, right hand side all other remaining people. So it will leads to n plus T of n minus 1. If you apply right, if you apply the substitution method, it will goes to order of n square. Time complexity of the quick sort, worst case n square it will become. If array is already sorted, or right, already sorted in the ascending order or descending order, right, it will goes to order of n square time complexity. So this is the analysis of the, right, quick sort. This is the analysis of the quick sort. Now next one. So remember, if you see the comparisons between merge sort and quick sort, if you see the comparison, right? So both are following divide and conquer. Merge sort, quick sort, both are divide and conquer. A basic idea is it will partition the given array, right, surrounding pivot element. But here in the case of merge sort, blindly divide into two parts. Blindly divided into two parts. Right? But if you see the divide step here, partitioning based on the pivot element, but here simply divided into two equal parts. But if you see the conquer, right, on the left side, right side, apply the recursion. Conquer means recursion. Okay, that's okay. But if you see the combine step, in the quick sort, no combine, because already sorted. After conquer over in the quick sort, it is already sorted. But in the case of merge sort, merge two sorted halves. Right? In the case of the merge sort, merging required. In the case of the quick sort, merging not required. In both the cases, you have to apply divide. So both are following divide and conquer technology, or divide and conquer designing technique. But in the case of the quick sort, division is done based on the pivot. In the case of the, right, merge sort, division is done, right, blindly two parts. In the case of the quick sort, no combine, but in the case of merge sort, combine is there. So if you see the time complexity is the best case, both will be n log n. Average case, both will be n log n. Worst case, right, one is right, quick sort is n square, worst partition, right, merge sort is always n log n. So if you want always n log n time complexity algorithm, you want always n log n worst case time complexity algorithm, then go to merge sort. Then go to merge sort. Suppose if you want a practical algorithm is a quick sort, because if array already sorted, no one will sort. Quick sort will give worst case n square if array already sorted, or in the ascending order or descending order. If array is in the random, quick sort will give best performance. Practical algorithm is a quick sort, right? On any input, merge sort is always n. If you don't want to take risk, go for merge sort. If you think that practically means array is not at all sorted, random array, then go to quick sort. But remember, quick sort worst case n square, right? Merge sort is always n log n. Right? Now let's go to next one. How much space? If you see the space complexity point of view, what about auxiliary space? In the quick sort, in the quick sort, so recursion is going to be log n stack space required. Stack space maximum is log n. In the merge sort, I think whenever merging is going on, one extra array you have to take. Because of this extra array, right, merge sort is not in place. Right, is in place or not? No, but quick sort is only log n, it is in place. But if you see the memory efficiency, quick sort less, it's a more efficient, it is a less efficient. Right, so right, space point of view, quick sort better. Fastness point of view, quick sort better. Both are following divide and conquer designing technique. Both are following divide and conquer. Both don't have combine. Quick sort don't have combine, but merge sort having combine. But both are having divide. Time complexity of merge sort always n log n. Quick sort is worst case n square. That too if array already sorted. If array already sorted, who will sort? That is the reason. Quick sort is a practical sorting algorithm. Quick sort is the practical sorting algorithm. Just I explained to you how the partition algorithm will work. Take one more example and check. So some people are asking partition algorithm. Sir, what is ISAR? Right? What is ISAR? So it is a low assume, it is a high assume. So remember I is equal to low minus 1. Now J loop is going on from low to high minus 1. J loop is going on. So J value, J initially low, next low plus 1, low plus 2, low plus 3. Whenever you got the smaller value, when you are checking like this, smaller value are equal, then I will increment by 1. Whenever you see smaller or equal, I will increment by 1, swap with J. Suppose, right, A of I is A of J is always more is coming. If more is coming, you don't need to do anything. So I think you will go to the out of the if, right here. You will go to again as usual, J plus plus. More coming, J will increment. More coming, J is incrementing. If small coming, I will increment. Right? Small is coming, I will increment, swap. If more is coming, J will anyhow will increment. Every time J will increment. More is coming, J will increment. Small is coming, I will increment, swap. Right? Lastly, at the end of the for loop, lastly swap with the pivot element and I plus 1. Return I plus 1. It will return the position of the pivot element. So now pivot element is sorted, left people not sorted, right people not sorted. And left people call the recursion. And right people also call the recursion. Right? I think I explained it very carefully. Very carefully I explained the sorting algorithm. Right. Thank you, Lepakshi. Thank you so much. Thank you. So I think today we are going to discuss the quick sort. I already explained clearly. Remember, so many partition algorithm is there. You can go to whatever partition algorithm you like. Whatever partition algorithm you like, you can go ahead. In the last class, I explained the merge sort. Here I explained the quick sort. Last class, I explained the merge sort. Here I explained the quick sort. And one more thing I want to say to you. If you want to be good in the DSA, if you, right, you know, any company you go, any software company you go, right, in the DSA round, you should be good in the DSA. In the campus placement, DSA is must and should. Right? So if you join this DSA course, whatever is going on, if you join this DSA course, then what happened is, this DSA course you joined, what happened in 2 months, right? In 1 month, you will complete the algo. In another month, you will complete the DS. In 2 months, DS will be over. In 2 more months, practice will be done. Practice of 500 problems will be done. So if you can do this, most probably you are very good in the DSA, right? So let me check one small thing, right? So DSA course, this course you can take, or DSA with the system design, you can take this course also. You can go to the DSA or system design, or you can go to only DSA. 60% discount going on, please utilize. Right? You can use the code 60% discount going on, EPT 610 EPT. You can apply this. Use this code, right? You will get the advantage. Fine. Let me know if anyone having any doubt. Small doubt also that this is our WhatsApp number. Please ping us. We are going to help you. This is our WhatsApp number. You please ping us. We are going to help you. Right? Fine. So yesterday I explained to you merge sort. Today I explained to you quick sort. Careful everyone. Yeah, thank you. See you in the next class. Thank you. See you in the next class. Right? Yesterday, merge sort. Today, I explained the quick sort. Tomorrow, I want to explain heap sort. Tomorrow, I want to explain heap sort. Little doubts also there, you can ask me. Little doubts also there, you can ask me. I will help you. Sir, I have this doubt. You ask me, I will help you. Check one time. Everyone check. Everyone have to ask. Little doubt also there, you can ask me. Sir, I have this doubt. You ask me, I will help you. Thank you. Tomorrow we'll see the heap sort. Fine. Thanks everyone.